Hello everyone, good morning. I hope you all are fine. And our today's topic, which we'll be studying, that is AGP, which is Arithmetico Geometric Progression. All right. So let's start with our topic, which is AGP. This is your AGP. All right. So what do we understand by the term AGP, Arithmetico Geometric Progression? That this contains two different terms, two different objects in the whole sequence. Since a progression is a sequence, that's why I'm talking about sequence. So the two different terms which a sequence would contain, those terms will be, one will be all the terms of an AP, and the other one would be the terms of a GP. That's why it is known as AGP. All right, AP as well as GP. So let me write one sequence. Suppose this is a sequence which contains some terms like 1, the other term is 2x, third term will be 3x square, next term is 4x cube, other term is 5x raised to the power 4, and so on. So in this sequence, I can clearly see that the first term is 1, the other term is 2x. So it contains the first term. It contains just one term, 1, which can also be written as 1 into x raised to the power 0. All right. Then in the other term, there's 2 and x. In the other next term, there's 3 and x squared. Then 4 and x cube. So you can see this 1, 2, 3, 4, 5. All this form an AP, as well as x raised to the power 0, x raised to the power 1, x squared, x cube, x raised to the power 4. All this forms a GP. So seeing the individual terms, you can find out that it contains both the terms of an AP as well as a GP. So that's why it is known as AGP. All right. Taking one more example, suppose we have 1, then we have 5x, then we have 9x squared, then we have 13x cube, and so on. This is also what? This is also an AGP. Moving on, let me take one more example as a plus d times x, a plus 2d times x square, a plus 3d times x cube, and so on. You would be wondering that sir is always writing x, x square, x cube, x square, x cube. No issues. You can take any value for x. All right. So if I take in this example itself, if I take this is 1, 5 times 1 by 2, 9 times 1 by 2 whole square, 13 times 1 by 2 whole cube. So this would also represent an AG. I hope all the examples are very clear to you. Now, moving on to the next thing, that the most important thing in all sorts of these sequences, whether it is AGP and the very next topic which we will be studying, the most important thing is writing the general term for it. The important thing to remember, that would be writing the general. That is your TR or TM. Okay. So if I take up this first example, so the general term for this would be, let me denote it by TM. So Tn would be what? The first term is 1, then 2x, then 3x squared, then 4x cubed, and so on. So Tn would be representing what? T1, T2, T3, T4, T5, and so on. So first of all, let me write the general term for the AP. So the general term for the AP would be 1, 2, 3, 4, 5. So that can be given as n. Now if I'll put n equal to 1, so I would be getting the first term. N equal to 2, I would be getting the part of the AP in the second term. Next in the third term, next in the fourth term. N represents the position. After that, here it's written x raised to the power 0, x raised to the power 1. Now the part for the GP, the common difference, the common ratio. So for the common ratio, I will be writing x raised to the power n minus 1. This is your general term for the first part. In the second example, what will be the general term? So the general term would be, now first of all, let us find out that what is the general term for the AP, for the terms of the AP. So this AP, here it is 1, 5, 9, 13, and so on. So this AN would be given by first term plus n minus 1. D is what? 4. So 4n minus 3. So now I can easily write 4n minus 3 and x raised to the power n minus 1. Because in the first term it's written x raised to the power 0, in the second term it's written x raised to the power 1. So x raised to the power n minus 1. Now moving on, we have third example. So let us write the general term for this. So in the third example, we are given what? A plus dx. Tn would be a plus n minus 1 into d, x raised to the power n minus 1. Now in the fourth term, Tn would be 1, 5, 9, 13 once again. 4n minus 3 and 1 by 2 whole raised to the power n minus 1. I hope this is clear to all of you. So the most important thing to remember that is writing the general term. All right. Now we will be focusing on how to write the series for AGP and how to calculate the sum. So suppose we are given a series, AGP series, which I am denoting by Sn. Sn denotes what? The sum till the end terms. So you can also see that this is the proof for the AGP series. Sn. So let me write the first term as A, the next term as A plus B times x. Next term as a plus 2b times x squared, and so on. Now the general term, seeing the general term, what is the last term? A plus n minus 1 into d x raised to the power n minus 1. Oh, very good. Very good. Okay. Now what we'll do? Here, there's a simple approach that you must keep in mind. I'll again write this whole series. Whole. Okay. Listen. But one thing that I would be doing in the second one, in the second series, that I would be shifting all the terms by one position. But position, that is 1. Now I'll be writing this A beneath this A plus D times x. So A plus D times x, and so on. So beneath this, I would be getting n minus 2 times D x raised to the power n minus 2. And this would be a last term. And my next step would be, what is the common ratio over here for the GP? Common ratio is x. Common ratio is x. If x is your common ratio, then I'll multiply the second series by that common ratio, which is x. So if I'll multiply by 1x, all the terms would get multiplied, and this would be ax a plus b times x squared. Now this would become n minus 1, and this would become n. So this would help us in what? subtracting both the series. This would help us in subtracting both the series. How? Let me change the signs if I want to subtract. Let me put a minus sign over here, then a minus sign, then a minus sign, minus, minus, and a minus. All right. Now, this would be 1 minus x times Sn would be a plus d times x minus ax. So this would give us dx plus dx square plus dx cube dx raised to the power n minus 1 minus of a plus n minus 1 into d x raised to the power n minus 1. Now, as you can see that here, dx square till dx raised to the power n minus 1, all these terms are in GP. So you can easily find the sum for these n minus 1 terms. How many terms are here? These are n minus 1 terms. So this would become a plus dx times 1 minus x raised to the power n minus 1 whole divided by 1 minus x. I hope this is clear to all of you. Minus a times n minus 1. This is what? A plus n minus 1 times d x raised to the power n minus 1. And this is 1 minus x times Sn. We need to find Sn. So Sn would be a upon 1 minus x plus dx times 1 minus x whole raised to the power n minus 1 whole divided by 1 minus x whole square minus a plus n minus 1 times d x raised to the power n minus 1 whole divided by 1 minus x. I hope this much is clear to you. So this is the proof for your sum of n terms which are in AGP, which are in AGP. All right. Now, in AGP, in all the questions for AGP, you don't need to follow the result. You don't need to remember the result. Here, the important part is the whole procedure that we just saw. So you need to practice and practice more and more the procedure which we just followed. Okay. So just focus on this procedure, and then moving forward, we will be doing what? Doing the examples for this. And all the examples which we will be solving by following the whole procedure, not simply by remembering the result. All right. Now moving to the next example. Suppose we have an example which says that you need to find sum up till n terms for the series 1 plus 2x plus 3x squared and so on. So what will be the general term for this? The general term would be nx raised to the power n minus 1. Very well. We just saw. Now what will be the first step? We'll be again writing this Sn beneath this and shifting the whole series by one position. So 1 plus 2x. Here this would be n minus 1 x raised to the power n minus 2 plus n x raised to the power n minus 1. And then multiplying the whole series, the second series, by x, which is a common ratio. So this would give you x squared, x raised to the power n minus 1, and this would be x raised to the power n. Now subtracting both of them, what we will be getting? 1 minus x times Sn, and this would be 1 plus x squared plus x raised to the power n minus 1 minus n times x raised to the power n. Now, luckily, what we are getting right from the beginning, right from the first term 1 till x raised to the power n minus 1, all the terms are coming in GP. Previously, we saw that from x till x raised to the power n minus 1, these were n minus 1 terms which were coming in GP. But now what happened? Right from the beginning, right from the first term, that is 1 till x raised to the power n minus 1, all the terms are in GP. So these are n terms. Okay. Don't fall in the trap. These are n terms. So for the n terms, 1 minus x raised to n upon 1 minus x minus n x raised to n. This is a 1 minus x times s. So Sn would be what? 1 minus x raised to n divided by 1 minus x whole square minus nx raised to n whole divided by 1 minus x. I hope you followed the whole procedure. Alright? So you need to practice more and more the procedure which we just saw. Alright? Moving to the next question. Suppose in the next question we are given Sn equal to. The terms are 1 plus 3 by 3, 5 by 3 square, 7 by 3 cube. Now, first of all, you tell me that what will be the nth term. So 1, 3, 5, 7, all these terms are in AP and these are the terms, so odd terms. So what will be the general term for the odd terms? 2n minus 1. This would be 2n minus 1 whole divided by, and this would be 3 raised to the power n minus 1. Now writing again this Sn and multiplying this by 1 by 3. So this would be 1 by 3 plus 3 by 3 square plus 5 by 3 cube and 2n minus 3 upon 3 raised to n minus 1 plus 2n minus 1 upon 3 raised to subtract, subtract, subtract with a minus sign as well as here also. This would give us 2 by 3 times Sn and this is 1 plus 2 by 3 plus 2 by 3 square plus 2 by 3 cube and 2 by 3 raised to n minus 1 minus 2n minus 1 upon 3 raised to n. So this would be giving us a GP for n minus 1 terms. 2 by 3 times Sn equal to 1 plus 1 plus. Let me take 2 as common. Then first term would be 1 by 3. 1 minus 1 by 3 whole raised to n minus 1 divided by 1 minus 1. Alright? Minus of 2n minus 1 whole divided by 3 raised to. This is the result which we will take. Here it's 2 by 3. Here it is also 2 by 3. Both of them would get cancelled. Correct? And you will be left with your result, which is 2 by 3 times Sn. That can be written as 1 plus 1, 2 minus 1 by 3 raised to n minus 1 minus 2n minus 1 upon 3 raised to n. Alright? Just cross multiply both the sides by 3 by 2 and you will get your answer. I hope this is clear to you all. Alright? So this is the part for AGP and where you have to find the sum for the n terms. Sum for the n terms. Okay? In the next lecture, we will be discussing the sum for the infinite terms in AGP. And that is very similar to the sum of infinite terms in a GP. So practice more and more whatever we have studied today. I hope you understood all. Alright? Thank you. All the best.